are. That's it. And yet I tell you that there's identities and proofs. So what we're going to do is we're going to list. There's only two rules. Only two rules. Only two tools to use. There's only two tools. Here's the first one. Tan theta equals sine theta over cos theta. That's it. That's one of the rules. And the second one is sine squared theta plus cos squared theta equals 1. Now, Dana, just because this is something that you and I were talking about, you need to know their names, right? Because a multiple choice question may just refer to them as their names. And so that's, we need to know their names. So this is the quotient, ident, and this is the Pythagorean, ident. You need to know that. Now, there's some, I got some helpful hints there. There is one rule to the game. There's one rule. There's one rule. The rule is you may not cross the, I don't want to say the equal sign because there's not the, but you may not cross the line between left-hand side and right-hand side with any terms. So what that means is you can't take something from the left-hand side over to the right-hand side and something from the right-hand side over the left-hand side. Whatever side it's on, you're done. And that's the only rule. And you can think about that and use your own words any way you want, but that's it. That's the only rule. That's the only rule to the game. It's it. It's the only rule. So how do you play the game? What's the goal? Well, the goal of the game is I'm going to give you a start. I'm going to give you a left-hand side and a right-hand side. And that's what I'm going to do for you. I'm a nice guy. You need to find the steps to show that they are equal. You need to find the steps to get there. You got to find the path. You got to find the path. That's up to you. That's so here's what the game looks like. You're going to have a left-hand side. You're going to have a right-hand side. And some of you are going to go in a very nice straight path. And some of you are going to go in a nice straight path the other way, which is perfectly fine. And some of you are going to go to a middle point and a middle point, and that's perfectly fine too. And there will be variations on a theme. Some of you will go around and around and around and around for 8 days and then finally make it. In which case I'm going to tell you to go back and make a better solution, right? It's a solution. It's a solution, but it's not a very good solution. We want to be succinct. We don't want to have circular logic. We don't want to go around in a circle. We want to be brief, and we want to not skip any steps. So you're going to look for be succinct. That's a great word. I think I need help spelling it. Does anyone want to help me, or should I try Google? Succinct. Succinct. No one wants to help me spell it. You're all a bunch of crazy kids. Succinct. Succinct. You want to be succinct. And that means the shortest, easiest path is always the best, okay? So you're going to want to be succinct. You say it too many times, you lose the ability to say it. B, you want to be clear. You don't want to skip steps. The ideal solution would be one that A, B, C, D, E. E comes after C. The ideal solution would be something that everyone can follow. And when I say everyone, it's a subset of the domain of everyone. It's just everyone in class. So everyone in class should have an equal ability to read your solution and understand it. If you have a solution that you're the only one that can read it, or maybe 2 or 3 people can read it and understand it, that's not a good solution. No, that's not a good solution at all. I probably, if that's the case, you've gone against C. You've probably skipped some steps. And the last thing is you don't want circular logic, A, B, C, D, E, F. No circular logic. And what that means is once you've made a step forward, let's not come back on ourselves and go back to where we were before. This type of making one step forward only to, and 2 steps later, come right back and undo what we did. So no circular logic. If there's any circular logic, then I'm not pleased at all. So this is the goal. This is how you win. This is winning. This is the game. And what are the rules of the game? Well, there's only one rule. And what can you use? You've got 2 tools, but you've got one other thing in your back pocket that you can use, and you're always able to use this, and that is algebra. And that's probably what I'm going to use more, way more than I use these 2. I'm going to use algebra a whole bunch more than I use those. They're going to come in, they're going to be important, but the algebra is what we're going to have to use. And it's easy algebra, in my opinion. I think you'll be fine. So I don't think I've ever laid this out nearly. I have to tell you, COVID-19 learning, there's some benefits. I don't think I've ever laid this out quite as nicely. So take a picture of that. You got that. And let's do a question. Let's see what this looks like. You got it? All right. You know what I would do if I were you? I would take a screenshot of that and put it on my phone. And then when I'm doing my homework, when I'm doing these, I'd have that open. So it just reminds me of what's going on. Oh, you know what? I can give you some helpful hints. I didn't give you my helpful hints. There is a list of Mr. White's helpful hints. I forgot about Mr. White's helpful. So Mr. White's hints. I can't spell hints. So sad. Mr. White's hints. To win the game. Yeah, no, I play to keep, man. I play to keep. I want you to win. Okay, so here are Mr. White's helpful hints to win the game. Number 1, start with what Mr. White thinks is the more complicated side. So what that means is I want you to start with the more complicated side, but we may at the very beginning have a difference of opinion which one it looks more complicated. You may disagree with me, and then I'll show you what I'm talking about, and then I think you'll come to agree with me. But we're going to do with what I think or what I teach. There we go. What I teach is the more complicated side, and that'll come to you, because I certainly don't want you emailing me before you do every question, say, Mr. White, which side's more complicated? No, we don't want that. Number 2, you know what? Try to change everything into sine or cosine. Just a little helpful hint, you know. When I look at them, I say, okay, well, let's make everything sine and cosine and let's go for it. Because we may not have sine and cosine, there may be the dreaded tan in there. Maybe the dreaded tan, and that's always a scary thing. Always consider factoring. Always consider factoring. And we're talking about things like common factoring. We're talking about difference of squares. And we could even be talking about trinomial. Always consider factoring. You should also always consider expanding. And so that's the distributive property. Distributive property. Always consider factoring, always consider expanding. Always consider common denominators. Not sure why that word got broken into two, but it did. So if I have b over a plus c over a, that's going to be b plus c over a. This list isn't going to mean anything to you until you've done some questions and you go back and read it again. This list is just you copying things out. It will make more sense after you get a chance to do it. And so I understand that you're writing this down and saying, I don't know what this means. And you're right. That's part of this learning. Right now, you don't know how this is going to affect you. I want you to remember algebra, which actually is all of this. But I also want you to remember things like, I don't know, that sine theta plus sine theta perhaps could be written as 2 sine theta. What do you think? That if I have a sine theta plus a sine theta, then that's the same as 2 sine theta. What do you say? And then if I have a sine theta times a sine theta, that in fact would be a sine theta squared, which we would write like that. I think that would be a good thing to remember, don't you? So I think what I can say is all algebra rules apply. And do I have a last one? I do. I have one last hint for success. Sometimes you will work the left-hand side only. Sometimes you will work the right-hand side only. And sometimes, sometimes you will work both left-hand side and right-hand side to meet in the middle. Well, yeah, that's not the right meat. That's like meat on a hamburger. Meat in the middle. Well, young Jedi Knights, that's the most I can share with you. That's all I got. I got nothing else for you. The only thing I can do now is do some examples with you. The rest is up to you. Yeah. The rest is up to you. We're sending you forth into the world. All right. Can I get rid of this? Nobody's saying anything. Let's see if anyone screams. No one screamed. All right. Hey guys, don't lose your energy. Don't lose your energy. Grade 12, this is a huge topic. It's a huge topic. So we've got assessments on it that I'll be doing. But in grade 12, they're going to assume that you've practiced this and you're good at this. So don't lose your energy. So let's prove that cos theta tan theta over sine theta equals 1. That's the question. What do you think of that? That's the question. So I've got a starting point. I've got an ending point. I need to fill it in. So the left-hand side is going to be cos theta tan theta over sine theta. And the right-hand side is going to be 1. Now, I don't want to, I suppose I could. All right, I will, because that's the way I set it up. Zoom. There's the line you cannot cross. Right? That's the equal sign. That's the line. I cannot cross. I can't take things to the other side. If you take things to the other side, you've broken the rule and you don't win. That's it. You get yellow carded, you get red carded, you're gone. Can't go over. All right. So if I can't go over, I need to work with one of the sides. Now, which side is most complicated? Well, I'm going to tell you, I think we all agree that the left-hand side is most complicated. So I'm going to work with the left-hand side. Okay? And I'm going to look at the left-hand side. I'm going to say, I wonder. And off to the side, because are you listening to me? You have to prove to me that you know what you're doing. It's not good enough just to get I've given you the answer. You literally have to prove to me you know what you're doing. And I'm not an easy sell. You have to prove to me. The onus of responsibility is on you, always in a proof, to prove to me that you know what you're doing. So do you see this tan here? I know that tan is equal to sine over cos, and I think you know that too. But I want you to write it somewhere so that I know that you know what's going on. And look what I'm going to do. I'm going to do cos theta is now sine theta over cos theta. But over here, I'm telling people what I'm doing. So this is my thinking. And as we get better at this, you can stop doing some of the thinking. But right now, I think there's value in me forcing you to show me what you're doing. So we took tan and we replaced it with sine over cos. All right. So now, algebra. I'm going to look at the top. Do you see what I see? This is what I see. I see cos theta over 1. I see sine theta over cos theta, all over a sine theta. Well, I see a reduction there. So this is going to be sine theta over 1 on the top, over sine theta. I know that looks weird, and that's going to throw a few kids off. So let's stop writing it that way. Let's just make it sine theta over sine theta. Well, sine theta over sine theta is 1. And if you look, I just won the game. Left-hand side equals right-hand side. And if I want to be particularly obnoxious, QED. And I'll zoom out a little bit. Let's see, can I get the whole thing? Not really, just missed it. There we go. But you're kind of missing, like, that's, if I do that, it's just, you miss too much. So there, good enough. Good enough, as my father-in-law would say, good enough. And that's how you're going to do this math. Doesn't look like math, does it? Certainly doesn't look like math, but it's math logic. And welcome, and we've talked about it a few times. We're starting to make you think mathematically. This is a logic type problem. I'm not interested in the answer. The answer means nothing. I've given you the answer. What I care about is this and this. Is it succinct? Yes. Is it straightforward? Yes. Can everyone in class follow it? Yes. Is there any circular logic? Do I go back on myself? No. It's a good answer. It's probably the best answer that is available there. It's not the only answer. And you know what? I'm going to do another answer to it. I just saw it now, but I'm going to do it just because I think there's value in me showing you that there's another answer. So let's see here. It's going to be A was prove cos theta tan theta over sine theta equals 1. It's the exact same question. The exact same question. So I'm going to start off with the left-hand side. And I got a right-hand side. And the right-hand side is 1. And the left-hand side is cos theta tan theta over sine theta. And we get the Gandalf line that we can't cross, which is the equal sign, right? You're not allowed to cross that. He can't, anything from here can't go over there, and he can't go over there. Just can't happen. You do realize that there's I have no help. There's nothing to help me to go from 1 back over to here. That it's not gonna. Do you realize what that logic statement's like? It's like this. It's like this. If I told you that I had 2 numbers that add together to give 8, and I asked you what the numbers are, there's an infinite number of answers to that. There's an infinite number of x and y's that can go together to give 8. But if I told you that I had 2 plus 6, there's only one answer to 2 plus 6. It must go to 8. That's the problem with the 1. If you try to go backwards with the 1, yeah, no, there's an infinite number of things that could have gone together to give 1. But to go from here to 1, yeah, there's only one way. There's only one, well, there may be different paths, but it will only either go to 1 or it will only go to a different number if it's going to go. There may be different ways to get there, but we can always get to 1. But to come back the other way, that's a different logic issue. That's tougher. So that's a good thing that we talked about that. Now, something I want to look at here. Do you see this sine over cos? This could be rewritten as, now do you remember the mix and max I've been talking to you about, that all of this thing could be regrouped like this? And that's something I've talked to you about. That's important, that it could be cos over 1, it could be tan over 1 times 1 over sine. So I can rearrange this, and perhaps I choose to rearrange it as cos over sine times tan. That's fine. That's fine. There's nothing wrong with that. I'm good with that. I'm going to look at this sine over cos, or this cos over sine. We know that tan theta equals sine over cos. We know that. So if I was to make it tan over 1, I could flip both sides. And the equality would stay true. I taught you that. That's just algebra. So cosine over sine is actually 1 over tan. And what that is tan over tan. And that's going to be 1. And I got left-hand side equals right-hand side. And if I want to be particularly obnoxious, QED. And ladies and gentlemen, I don't know. I don't know which one I like better. I'm going to be honest. They're both great. I would give full marks to both of them. They're lovely. They're perfect. I think there's a little bit more math happening here. There's some more algebra happening here because I got to know about the reciprocal. And because I did a little bit more math, it made it shorter, whereas this one took a little bit more. Not a lot more. Not a lot more. There's 2 answers to that. Take a picture. Take a picture. All right, let's get rid of that. Let's do another one. And both of those are good answers. I'll take both. So example B. Prove. Cos x equals 1 over cos x minus sine x, tan x. Oh my goodness, Mr. White, what are you doing? What are you doing, Mr. White? Now, notice since it says prove, we can assume that it works. And that's something I haven't really broached that. Sometimes we have identities that don't work, and you have to prove that it's not true. That's harder. That's harder. But for the most part, 98% of every question you'll ever get, the identity will be true because they're telling prove this. And if I say prove this, and if this isn't provable, that's kind of mean, right? So the question should say prove or disprove. But in this one, it just says prove. So we're going to make an assumption that it's definitely solvable. And if I can't find it, I haven't done everything I need to do, that there's something else I haven't done. So the left-hand side is cos x. Nice. Right-hand side is 1 over cos x minus sine x tan x. And we have where the equal sign goes, this is what we have to prove, is that we can take this and get that, or take this and get that, one or the other. Or both. Meet in the middle, I don't care. I think it's pretty obvious that this is the more complicated side. And in mathematics logic is that we can take a bunch of disorganized things, a big bunch of operations. In mathematics, the theory is we can take a big bunch of operations and condense them down to a smaller group. And that's basically what is called simplifying. Right? Collect like terms. Right? Simplifying. We're basically simplifying. So I don't want to work with the cos x. There's nothing to do with the cos x. I can't do anything with it. So the more complicated side here, and I say complicated, I should say rich. It has more rich opportunities. There's more things to do here. First of all, I see a 1 over cos x. That's exciting. I see a tan x. Ooh, that's exciting. So I got some exciting things happening in my life right now. So let's go here, and I'm looking at the tan x. And I'm saying, okay, so tan x equals sine x over cos x. So let's replace the tan x with sine x over cos x. So 1 over cos x minus sine x is sine x over cos x. So that's just a straight substitution. But you're going to tell me what you're doing because you want me to understand, right? You do. You really do, because I'm the one that's going to give marks. And if you don't prove to me without a shadow of a doubt that you know what you're doing, I just won't give you the marks, and that'll be sad. Okay, so what have we got going on here? I think I want to do a little bit of algebra here. Do you see what I see? Do you see what I see? I see a sine x times a sine x. Last time I checked, something times itself was itself squared. So I don't really think you need to write this, but I'm doing it just because I don't want anyone to be lost. I don't think you need to write that one, but there you go. That's what I did. That's what I did. That was my next step. Oh, the next thing. Do you see what I see? I see a common denominator. Yeah, that's what I saw. I saw a common denominator, so I took the two cosines and put them together. All right, well, now I'm kind of stuck, although I see a sine squared, so wait a second. I see a sine squared on a 1. Wait a second. My memory, if I remember, wait, there was something, wait, it was sine squared theta plus cos squared theta equals 1. But this is 1 minus sine squared. It's not the same. This one has the sine. This one has cos squared theta equals 1 minus sine squared. That's not. Oh, wait. I got 1 minus sine squared theta, and I got 1 minus. Wait, those are the same. So that means I could replace this with a cos squared. Okay. Do you see what I see? So that's nice. So at this point, I'm a little exhausted, and I look at what I've got, and I look at what I want. I look at what I got, I look at what I want, and I realize I just want one cosec's. And I realize I got a mess of cosec's here. In fact, I got two cosec's on top, and I got one cosec on the bottom, and they're all talking away at the same time and jibber-jabbering, and they're annoying. They're just so annoying. So let's get rid of one on the top and one on the bottom because, you know, it's just multiplying and dividing. So let's get rid of them. They're annoying. Oh, my word. Left-hand side equals right-hand side. I win.
Sir?
Yeah.
Can you explain the step before the cosine x?
This one? This one?
I cannot see it.
You cannot see it. Why not? How about
Wait,
now?
my video is buffering at me.
Were you the one that was having problems with your video earlier?
Yeah. I don't know. I had to have like 2 meetings open and I had to like keep switching between them.
I'm so sorry. Is anyone else experiencing as much difficulty? So this is what's going to happen, Dana. You can always watch the video after and get a more smoother.
Yeah, that's what I was going to do.
Yeah. Can you see now?
Are you like pointing at it?
I am.
Because it's not showing though. It's the step after 1 minus sine x, sine squared x over cosine x.
Okay. So you know what you're missing? Let's come over here. Maybe can I'm going to try to help you. I don't know if it'll help you, but I'm going to try to help you. Okay. I'm going to go to this again, and I'm going to go to this again. And I'm wondering, can you see me move around now?
Yeah, it's good now.
Okay. So you're having a no, I'm fine. You're having a bit of an issue coming from here to here, right?
Yeah.
Okay. So do you remember 1 minus sine squared? No, you don't. So that's why I went over the whole thing of putting this over here. Do you remember sine squared theta plus cos squared theta 1 is one of your identities? There's only 2.
Yeah.
This is one of them. This is the second one, right?
Correct, yeah.
Okay, but this isn't cos squared plus sine squared or sine squared plus cos squared, is it? It's 1 minus sine squared. But look, I can create that if I take the sine squared.
Oh, I see it now.
Ooh,
yeah.
Yeah.
Okay, I see it. Thank you, sir.
Mr. White's a tricky guy. But you know what, kiddo? That would have been really hard to see if your video didn't show you what I was doing here. Okay? So you relax.
Yeah, it was, Okay, thank you, sir.
If you didn't have that, then that makes perfect sense. Anybody else?
Sir?
I'm happy to help you.
Sir?
Yeah.
I'm kind of lost.
Okay.
I get pretty much everything until you did the common denominator part.
Yeah. Okay. So, and this is what's going to be hard for a lot of kids, because if we're still working on some of the algebra stuff with numbers, this just makes it worse because there's no numbers anymore, right? So I'm going to write over on this side. And am I talking to Ariana?
Yes.
Okay, so Ariana, let's say I was talking about 1 over 3 minus x squared over 3. Okay, let's make it a little bit easier. Do you agree that they have the same denominator?
Yes.
So they're the same size fractions, aren't they?
Yes.
Which means I can take 1 and subtract x squared over 3.
Yes.
Okay, so that's what I did here. That's the common denominator. I took the cosec, and instead of a 3, it's a cosec.
I got that.
All right. Now this one. This next one, this next one's new, kid. I'm sorry, it's new. I have to recognize, just like Dana does, that this is very, very similar to one of the 2 identities that we learned today. Now, or actually, you learned it a couple of days ago, but this is one of the identities. Okay. And you're going to write it down on a piece of paper whenever you go to do your homework. You're just going to write them out. Okay. And then you're going to have them there so that you can look at them and say to yourself, All right, so when you get stuck like this, which one of these two identities does the top look most like? Does it look like number 1 or number 2?
Number 2.
I would agree with you. Now it's not number 2, is it? Because it's sine squared plus cos squared equals 1, and this is 1 minus sine squared.
Yeah, it's not the same.
It's not the same. But could we make it the same by moving that over there?
Yes?
Well, you say that like you're not sure. Let's take a look. Cos squared theta equals 1 minus sine squared theta. Did I make 1 minus sine squared theta?
Yes.
I did, didn't I? And so what does 1 minus sine squared theta equal?
Cos squared theta?
That's right. So look what I put here.
Oh, I see. And then because it's squared, that there's 2 of them, and then they cancel each other out. Oh, all right. I
Good job.
see it now.
No problem. Anybody else?
This might be like a dumb question, but I understand like everything that you're doing, but how do you just like know right away to do all those steps? Like I feel like if I did this alone, I'd be lost.
Hallie, thank you so much. And Hallie, you're going to be. I'm going to be honest with you. You're going to be. And yeah, yeah, you're going to be. And you're going to be frustrated, kid. And you're going to be angry. And you're gonna say bad things about Mr. White. You're gonna, and it's gonna be sad. And my ears are gonna be ringing tonight. But I'm gonna tell you, it's practice. And I make it look so easy, don't I?
Yeah.
Okay, so honestly, I've tried to teach you so it'll be easy too. So this is one of the things you're going to do tonight. You're going to go back over your notes. That's a big thing. And you're not going to attempt any of these questions. Now, all of you listen to this. Hallie asked a beautiful question, and I'm giving a gorgeous answer. Hallie, you have to start by having at your fingertips, these two identities.
Okay.
Okay, there can be no question about it, and you should get to the point where you've memorized them. Okay, and it just should be second knowledge, and that's your first step. And if you don't have those, you can't do anything else. So that's the first step. Now the next step is to understand the different variations that these can show up as. So the next is to understand that I could do something like this, right? The next is to understand that I could do something like this.
Okay.
And the next is to understand that I could do something like this. You asked a beautiful question, and I'm giving you a beautiful answer. That is your starting gate. If you don't have those at the very beginning, we can't move on. And this one, you have to be able to see that it's going to be also equal to fair enough?
Yeah.
So from the very beginning, we're going to have to know this. We're going to have to know this. And then from that, you have to know these. So let's keep this close by. Let's keep this really close by my side. And if you want to do your homework with something like this close by your side, that's great. But please understand that the expectation is that you're able to do it without. So maybe we need it for a little while, but then we're going to have to move away from this, okay?
Okay.
Okay, so next, you need to know the rules of the game. You can't cross the equal line, okay? You know that, right?
Yeah. Yeah.
Okay. Then the next thing you need to know is, let's try, these are my helpful hints. Remember I gave you the helpful hints? Helpful hints. Let's put those close by so that we can use them. The helpful hints that Mr. White said was, let me see, change everything to sine and cosine, which is just a way of saying get rid of the tans, right? That's what that says. Get rid of the tans. And then the next thing I said, my next helpful hint was Algebra. We got to remember our algebra. So we got to keep in mind factoring. Okay, we got to keep in mind factoring. We got to keep in mind distributive property. Okay, then we got to keep in mind common denominator. We got to keep in mind distributive property, common denominator, and reducing. How about just reducing? You know what I mean by that, right? Crossing out the top and the bottom?
Yeah, yeah.
Okay. And it's not really a helpful hint, but it's just life. I think we better remember that sine x plus sine x is 2 sine x's, and that sine x times sine x is sine squared x. And you know what? That's all you need. This is it. This is the game card. This is how we're going to win. Okay? So let's go play the game again. Let's go play the exact same game we just did that you just watched me do, and you said, I don't think I could ever do that. Okay? So let's take let's do it with the game card, okay?
Okay.
All right. You know what? I do like COVID teaching in some ways. We wouldn't have time to do this if it was a classroom, you know that? And I wouldn't have the same, you know what? There is some good stuff out of this. Okay, so 1 over cos x minus sine over tan x. Which in here is going to help me with and that's the next thing. Who am I talking? It's Hallie, right? Hallie, don't make the mistake of thinking that you're going to figure it all out in one step. You're going to do little, yeah, oh, I forgot that. You're going to do little steps. See, I don't care as long as I'm moving a little bit forward each time. I could move the tiniest little bit and I'd be a happy camper. And you guys, you want to sit down and look at this question and go, yes, I know exactly what I'm going to do for all 12 steps. No. Okay, so, and believe it or not, that's something that we're teaching you. To be resilient, to work through it, to do little steps, to keep a goal in mind, rather than just sitting there and saying, I know all 12 steps. No, that's not math anymore. Okay, so I'm excited, you're excited. What's going on here that maybe we want to take a look at?
Taking the tan out.
I agree. So let's take the tan out. So it'll be 1 over cos, because I didn't touch that, right? So I don't get to mess with it. It's the sine x. I didn't touch that, so I don't get to mess with it. And it's going to be sine x over cos x. And because you have Mr. White and he's a pain in the butt, you're going to show him that you know what you're talking about. And I would agree, eventually we'll stop doing this because it's shown right there. But just for her sake right now, we'll see that we take the tan x and we changed it for sine x over cos x. Cool?
Yeah.
Okay. Always look for algebra before you jump around and do things. Algebra. Do you see this sine x? It's the same as sine x over 1. So this is begging to do a multiplication, don't you think?
Yeah.
Okay. So it will become 1 minus sine squared x over cos x I just did multiplication. All I did there was the sine x times a sine x is sine squared x. And I did it, but did you understand that we could do that?
Yes.
Would you have done that?
With some practice.
Okay, but I don't see anything else to do. I think that's the difference. Can you and I talk for a minute? Look, if this was 1 over 3 minus x times x over 3, I don't see anything else to do other than 1 minus x squared over 3. It just seems logical that that's my next step.
I think it's just harder for me to notice because, like, I'm not used to working with sine and cos x.
You've hit the nail on the head. You've hit the nail on the head. So can I show you what we do in mathematics? We start you off in grade school and we teach you this, right? And then you come to high school and we teach you that. Well, guess where we're at now? So we're doing all the same math, but with a function. If you really want to see what's happening, We're teaching you to do algebra with functions.
Yeah.
Okay, so you're absolutely right, my dear, and you've hit the nail on the head. The hard part for you kids at this point is treating that like x's. So what I would suggest is change them to x's on a scrap piece of paper if you need to. Who cares? All right, so what do you see next?
You can like omit one of the cos x's on the bottom, so you can just put 1 minus sine squared x over cos x.
I love how you said that. Omit. I'm not sure I'm going to let it slide. I'm such a pain, I know. I know what you meant, and I was able to do it. You're not really omitting anything. Can we say common denominator?
Yeah.
Okay. All right, now what do you want to do? And it's okay not to know. It's okay to look at it and say, and then when you go, here's what I suggest, think. Well, is there any algebra? Well, it's a difference of squares, but it's not going to help me. And I'll show you what that looks like in a minute. The difference of squares looks like this, and this is going to bother you because this is the same as 1 minus x squared, right? So a difference of squares would be 1 minus x and 1 plus x. So this will be 1 minus sine x, and it'll be 1 plus sine x. See, you're going to hate this, eh? Look at that. But it's the same thing.
Yeah.
But it doesn't help. It doesn't help. It doesn't help. So what about tan? Is tan going to help me in this? No, tan's not going to help me in this. What about this? Sine squared theta plus cos squared theta. Is that going to help me?
I think because you can rearrange it.
You're right. You can rearrange it. So I want it to be 1 minus sine squared. So I'm going to take the sine squared like we did with the Ariana. We're going to move it over there. We're going to get cos theta equals 1 minus sine squared theta. So that means that 1 minus sine squared theta, this part, can be rewritten as cos squared theta, or cos squared x over cos x.
Okay. And then do you just like expand the cos?
Well, yeah. So if you had x squared over x, or if you had a squared over a, or if you had 3 squared divided by 3, what would the answer be?
In
order, what would this answer be?
X.
What would this answer be?
A.
What would this answer be?
3.
And the reason is because you'd have x times x over x and they'd reduce. And the reason is you'd have a times a over a and they'd reduce. And the reason is you'd have 3 times 3 over 3 and they'd reduce. So guess what you have, child? You have cos x times cos x over cos x. And they reduce. Child, you just solved it.
Okay.
So, the answer to your question. Yeah, you're going to be frustrated. I know you are. Many of you are. Some of you are going to come out of the frustration and say, I kind of like it. It's kind of like a puzzle. There's not that many pieces. Do you see how I slowed it down for you?
Yeah.
Okay, so this is it. This is the only game card. That's it. There's not that much there. I have to be honest with you. You are right. Haley, you have hit the nail on the head. So we went from teaching you kids that 3 plus 3 is 2 times 3. And then we went to teach you kids x times x is 2 times x. And then we taught you that 2x squared plus 2x squared was 2x squared. Now I'm trying to teach you that sine x plus sine x is simply 2 sine x. The algebra is not changing, is what I'm trying to get at here. The algebra stays the same. What we use as the numbers or the variables or the functions is changing, but the algebra is constant. You have just, my dear, hit upon one of the major themes in mathematical education. And one of the major themes in algebra is that it doesn't matter what we work with. The rules of algebra remain constant. And that is a fundamental mathematical truth that you've just uncovered. Congratulations. That's huge.
Thank you.
Now, let's look at how it works, because I'm not going to let this go. This is a huge breakthrough that you've just done. So if we know that x times x equals x squared, then it follows that sine x times sine x is sine squared x. If we know that x plus x is 2 times x, it follows that sine x plus sine x is 2 sine x's. If we know that 5x means x plus x plus x plus x plus x, and now you're going to see why we don't use the pluses so many times, because it makes things look awful, that if I say 5 sine x, it means sine x plus sine x plus sine x plus sine x plus sine x. The rules of algebra don't change. How be we do a difference of squares factoring? A minus b, a plus b. Well, what if it was x squared minus 25? Well, that's x squared minus 5 squared, which was x minus 5, x plus 5. Okay, so it follows to reason that sine squared x minus 1 could be sine squared x minus 1 squared. So it's sine x minus 1 and sine x plus 1, which is very different than 1 minus sine squared x, because this has the 1 in front. So it's 1 squared minus sine squared x, which is 1 minus sine x, 1 plus sine x. And those are very different. Don't confuse the two of them. These two don't matter, but these two definitely do. Think about it. If I have 3 plus 1, it equals 4. If I have 1 plus 3, it equals 4. But if I have 3 minus 1, it equals 2. And 1 minus 3 equals negative 2. The order of subtraction matters. This and this have a different order. It matters. So let's do another difference of squares just to bug you. Look at that. It's a squared minus b squared. So it's going to be sine x minus cos x, sine x plus cos x. Do you see where I'm going with this?
Yeah.
Okay, you ready to be really freaked out? How about a trinomial? That is going to factor out to x plus 3 and x plus 4. You should know that. I think we should all know that. We're looking for two numbers that multiply to give 12, add to give 7, 3 and 4 work, and we put them in, and yay, we're brilliant. Look how smart we are. You really want to freak out your friends? Let's do this. Sine squared x plus 7 sine x plus 12. Compare the two of them. How different is this from me doing this? A squared plus 7a plus 12 will be a plus 3 and a plus 4. How different is it taking the x's and making them a's to now making them sine x's? Now maybe this throws you off a little bit, so maybe you want to look at it like this. Fine. And this gives us an answer of sine x plus 3 and sine x plus 4. What do you think, Haley?
It makes sense. It's just like hard to recognize at first,
Yep.
but it does make sense.
Good. Good. And you've hit the nail on the head. That's tonight's work. Practice making sense that we can do this with sines and cosines just like we do with x's, y's, and numbers, okay?
Okay, thank you.
No problem. Guys, that's enough for today. I'm going to give you some homework, obviously, and there's quite a bit of homework because you've got a bit of graphing to do. And you're going to have to do some identities. But I think what I'll do is I'll continue with identities tomorrow, and I'll stop there. So I think we're on to the very last topic. So I'll do identities more with you tomorrow, and I'll give you some time to do some identities tomorrow, and that will represent the end of the content for this course. So let me stop the video, and we'll talk to you just for a minute.